Now for number 3, we say we have table 1.1 shows the properties of 4 substances. So we have the substance aluminum, diamond, potassium bromide, and sulfur. Its boiling point, electrical conductivity when it is solid, electrical conductivity when it's molten, and its density are given. Each and every substance are given. Now question A says state the meaning of the term ionic bonding. So it's 2 marks, so you need to mention 2 things about ionic bonding. Remember the command term state. So you will not reason out here, you just need to state a fact regarding or about ionic bonding. So as far as I know, ionic bonding is a bonding between a positive ion and a negative ion. Okay? Which is bonding between a positive ion. So in this positive ion, we call that metal or a cation. Okay, so we'll just write a positive ion, which is normally are metals in the periodic table, and a negative ion or non-metals. Okay, non-metals. So non-metals. Okay, or what we call an anion. So since again there are 2 important details that you need to mention here, you need to state as well. Now, considering all the types of attraction that we have discussed so far for this unit, we know that ionic bonding is a strong force of attraction. Okay, it has a strong force of attraction, or the strong force of attraction. Alright, now again, for this question, you need to know this standard definition of ionic bonding. And as far as we have been defining this kind of bonding, an ionic bond is a strong electrostatic force of attraction between oppositely charged ions. And using the word particles instead of ions will sometimes get the second mark, but this is not guaranteed. Okay, so instead, don't use the word particles, but use the word ions. Okay, since it's all about ionic bond. Now for letter B, identify which information in table 1.1 shows the potassium bromide is an ionic compound. Okay, so potassium bromide, so we have this element, substance, potassium bromide. Why? It's asking us why, or identify which information, I should say, which information that shows that it is an ionic compound. So it's so easy. So we have here, it says here that the boiling point is high, and it does not conduct electricity when it is solid. Okay, and it conducts electricity when it's molten. And I think these 3 information is enough. So we can write it down. Okay, you can have it in bullet points. Does not conduct electricity Okay, you cannot end your answer by just saying does not conduct electricity. You need to specify when. So it's when solid. okay, when solid, but conducts when it's molten. All right, but conducts when it's molten. Okay, and as you can see, it's also mentioned in the table, it has high boiling point, so we can put that as our second answer. So it has a high boiling point. Okay, high boiling point. Okay, now once again, it's like a definition. Ionic compound cannot conduct electricity when they are solid, as the ions are not able to move. Take note of that. Ionic compounds can conduct electricity when they are melted, or when they are molten or dissolved, as the ions can now move. The boiling point of ionic compounds is high, as the strong electrostatic forces of attraction requires a large amount of energy to overcome. It's like what we have mentioned here. Okay, here. Now for letter C, magnesium, calcium, strontium are in group 2 elements. Magnesium reacts with chlorine to form magnesium chloride. So, magnesium chloride, okay, MgCl2. Magnesium chloride is an ionic compound. Complete the dot and cross diagram in figure 1.1 of the ions in magnesium chloride. Show the charges on the ions. Okay, so taking a look at the given figures, it says here we have magnesium, so the first energy level is given, and we need to, and then for chlorine, the first two energy levels are given. We know that magnesium is in group 2 elements, meaning it has a 2 plus charge. Okay, a 2 plus. Now, the careful for this kind of questions, because it says complete the dot and cross diagrams. There are not enough shells for each atom or ion here given, and which means we will have to add shells and electrons. Some answers will just have the charges and therefore miss out on 2 marks. So the two things that we need to indicate here are the new outer shell for magnesium, which will contain 8 crosses, I would say, because it's filled in. And for both chlorine, and for chlorine, the 2 chlorines here will have new outer shells, each containing 7 dots and 1 cross. So we have placed already the charge for magnesium, and there, so we have, let's put, alright, so let's put that so let's just put it in the center properly. Alright, so we're done putting the outer shell, and we can say, we can put, it uses a cross, so we put a cross here. Okay, full. Why is it 8? Take note that magnesium is 12, element 12 in the periodic table. So in this case, it shows, because it's 2 plus, it has given a 2 plus charge, or these transferred, the 2 electrons transferred to chlorine. And for chlorine, okay, so let's just put that at the center. Now, since it's a dot and cross diagram, so we'll be using a dot, so dot, and then we have a cross. Okay, again, let's make that a bit bigger. So we have a dot, and we have a cross coming from magnesium. So since it received 1 electron, so the charge of this is -1, or just negative will do for chlorine, negative. So the outer shell is not yet filled in, so we will put dot, dot here, dot, dot there, okay, and also here. Alright, same thing, we can just maybe like highlight this one. It's the same thing as this. Okay, I will just put the same, I'll just paste it here. So it will look the same with the other chlorine. And that's how we complete the dot and cross diagram for magnesium chloride and showing its charges. Again, take note, some answers will have just the charges, you might miss 2 marks. So please take note of that during the test. And for letter D, one physical property typical of ionic compounds such as magnesium chloride is that they are soluble in water. Give 2 other physical properties that are typical of ionic compounds. So it's like a repeated question from the previous one. Again, for ionic compounds, they have high melting point, I would say. Okay, they have high melting point. Okay, they have high melting point. We can also say, or high boiling point. Okay, high boiling point. I think I need any of this will give you a point. We can also mention that ionic compound is they have good electrical conductivity. Okay, they have good electrical conductivity. Alright, when they are when aqueous, I would say. So the state is aqueous solution, then it's a good conductor of electricity, or molten. Okay, I think this was mentioned in the previous questions. Alright, so that's for question 3.